Okay, we left off and have 7, 8, and 9 to do. And on 7, we're given this equation that is implicitly solved currently. And we're being asked to find the equation of the tangent line. Well, what do we need for an equation of a tangent line? Point and slope, yes?
Yep.
Okay, so what's that mean I have to do?
Find the derivative of that.
Find the slope.
Okay, we have to find the derivative to find the slope at that point, yes? So, how are we going to find the derivative of this?
We're going to use what we learned yesterday.
And what we learned is called
minus
implicit differentiation.
Yep.
Okay, good name to know. It's implicit differentiation. Okay, so derivative of x squared
2x.
minus derivative of xy.
Derivative of x times
We got to do the
dy
product
dx.
rule now.
Okay, so product rule. Now, beware, we are subtracting this product rule. So kind of beware there. And in fact, I think I'm going to put parentheses here. I'll show you can do it one of two ways. Product rule. Derivative of x is 1 times y as is. Now, because I put parentheses here, I'm going to go ahead and do my normal product rule and say plus. Now we're going to keep the x. Derivative of y is 1 and then dy dx. And I'm going to end my parentheses. Now, if you don't put the parentheses there, the other option is just to subtract both terms because there's subtraction in front of the xy. Make sense? Plus, what's the derivative of y squared?
2y.
2y dy dx
Equals 0.
equals, I was hoping you just said it wrong and you wrote it right, but
I didn't.
the derivative of 7 is 0. Okay? Now what?
Clean up.
I really don't know what to clean up. I'm not going to lie.
You want to
Oh, yeah, you want
wanna
everything
get
on
your
the same side.
dy dx is on the same side and everything else. Came to
Okay. So, does that mean you guys are keeping the dy dx's on the left?
Yep.
Yeah, sure.
So I'm going to write mine as 2y dy dx. And what do we know about the x dy dx term? It's minus x dy dx, right? Equals,
y.
it's a minus y, so I'm going to add y to the other side. It's a positive 2x, so I'm going to subtract 2x. Are you there? So we separated our dy dx's from our non-dy dx's. Now we're going to factor out the dy dx. Inside my parentheses, I'm left with 2y minus x equals y minus 2x. And then we can divide. I know, I was just realizing I'm going to run out of room if I'm not careful. dy dx is, okay, y minus 2x over 2y minus x. Now, that is my derivative. What do I need to do?
Plug in the points.
Okay. We need to take dy dx and evaluate it at -1, 2. That's my official notation there. Evaluation bar, and then we're evaluating it -1, 2.
You have the evaluation bar.
I mean, if you're going to do official notation and say evaluate at -1, 2, you should. If you just put dy dx equals and then just plug it in, I mean, I guess you could do that too. And what is this 4/5?
Your
4/5 is my slope, right? This is my derivative evaluated at the point. And the other part we need is the point, which they already have. So, did I get it right?
Hopefully.
So realize I didn't really talk about this picture here. This picture is what we would call a rotated ellipse. Because if you remember ellipses from last year, it's the ovals basically, right? We either had them as horizontal or vertical ovals. This one's just rotated, it's at an angle. So what we just did here is -1, 2. We did the equation of the tangent line at that point. So we did the equation of kind of that line, right? Give or take. Okay. B. Find the equation of the normal line at x equals -1, 2.
Isn't it just -5, y equals -5 over 4, x plus 1?
Now what's the key we need to talk about? What's normal?
Y equals perpendicular to
Okay.
tangent.
If you recall, normal is a variation of saying perpendicular. So my original slope was 4/5 that we found up on the previous part, yes? So my perpendicular slope is the opposite reciprocal. So -5/4. Realize that upside down T sign, that upside down T is your perpendicular notation. So writing the equation, y equals -5/4 x minus -1 plus 2. Easy when you've already done the first part there, isn't it? Okay, you ready? So, calculating higher order derivatives. We've done higher order derivatives already. Finding second derivative, third derivative, fourth derivative, fifth derivative, so on and so forth, right? The key is higher order derivatives when using implicit differentiation, okay? So you'll be sure to solve for dy dx before finding the second derivative or higher. The subsequent derivatives will have a dy dx term in them. For each of these terms, you can substitute to be able to put your final derivative in terms of x and y. So we're going to have several steps along the way here. So they're asking us to find the d squared y over dx squared given cosine y equals x. So they're asking me to find the second derivative. In order to find the second derivative, you have to find the first derivative. So, and again, of course, it's not solved for y equals because that's the whole point of this lesson. So, first derivative. What is the derivative of cosine of y? Derivative of cosine of y is negative sine of y. Did anyone say it?
dy dx.
Times dy dx. Because then it's going to be times the derivative of y. Well, the derivative of y is just 1, but then dy dx equals, what's the derivative of x? 1. Okay. So, in working with derivatives, we want to solve this for dy dx. So, dy dx is going to be
1 over -5.
Yeah.
the negative of 1 over sine y. You gotta have a negative there somewhere, right?
Mm-hmm.
Now, most of the time what you will see here is not leaving it in this form. What is another way to write
-5 y is -1.
What?
That makes sense. Negative cosecant. Y.
Okay, both correct. So the direction I'm going here with is we don't typically leave a sign or a trig function in the denominator unless we have to. So a sign in the denominator is equivalent to what trig function in the numerator? In other words, sine is the reciprocal or the inverse function with
Cosecant.
cosecant. So this is the same as saying, or the reciprocal, I should have used the word reciprocal, sorry. So this is the same as saying negative cosecant of y. Are we there?
Yes.
That's our first derivative. Now, let me touch real quick, because I am going to say there is an or option. Doug mentioned dy dx mean negative sine y raised to the negative first. That is also an option. And that is an equally valid option. Okay? And I guess that would be the way to go if you're going to struggle when we have to take the derivative of cosecant here in a moment. That would be the way to go. Because this is first derivative. Now we've got to find second derivative. Right? In order to find second derivative, you take the derivative of first derivative. So d squared y over dx squared. The derivative of negative cosecant y. So what is the derivative of cosecant of something? Almost.
Negative cosecant cotangent.
Negative cosecant cotangent. So the derivative of cosecant of something is negative cosecant cotangent of something. So the derivative of negative cosecant is going to end up being positive cosecant y cotangent y. And then times the derivative of the inside, so times dy dx. You've got to know those derivatives, right? It's a memorization thing at this point. Now, we've taken our second derivative. However, we can't leave our second derivative with a dy dx. What did we already figure out earlier?
dy dx equals negative cosecant y.
dy dx is negative cosecant y. So we replace? Yes. You're seeing where we're going. I didn't say you're liking where we're going, but you're seeing it. D squared y over dx squared is cosecant y, cotangent y, times
Negative cosecant y.
negative cosecant y.
Could we put it as negative cosecant y squared then?
Yes.
Wait, what?
So, okay.
Sorry.
We have cosecant y, cotangent y, times negative cosecant y. That's basically just three trig functions multiplied together. It's cosecant times cotangent times cosecant. There's a negative in there. It was like a negative times a positive, so that means it's going to be negative. You can say cosecant times cosecant, because they have the same insides, is cosecant squared y and then times cotangent y. Or you could say negative cotangent y cosecant squared y.
Wow.
Okay.
That was fun.
Could you have done the derivative using this or option with the negative exponent? You can. Okay, it's a negative power, so negative out front, subtract 1. Also doing the derivative of sine of something, and then the derivative of y. Now, what I will say with that is with a little work, it can end up looking the same. Although mine did not necessarily, I don't know. This one to me just seemed easier. Now, did we have anything else to do on this one? We don't, do we?
Questions about the last problem?
Ah, got it. Okay. Ready for 9?
Yeah.
Find the points at which this graph has either a horizontal or vertical tangent line. going to need derivatives, yes? Derivative. I don't know why I
And
made
is
that.
that
bold.
whenever it equals 0 then?
Well, we have to find the derivative right now. And then we're going to have to think about when our derivative equals the particular slopes. So let's find our derivative first. Okay? Derivative of x squared
2x.
plus derivative of xy
Y.
Y
Plus
dy
dy
dx.
dx.
X not dy dx.
Why would,
Are we all there?
yeah.
On the
Very confusing.
xy is a product rule, yes. I feel like this is new enough. I still need to make sure I go through it.
No, you're good.
xy is a product rule. Derivative of x is 1. Keep the y.
Mm-hmm.
Plus, now we're going to keep the x. Derivative of y is 1 times the dy dx, right?
Mhm.
Plus, derivative of y squared.
2y times dy dx.
2y, then times the dy dx. Derivative of 27 is 0. Is this the same derivative we took on number 7?
No, the other one had a minus.
That's literally the only difference.
And it had 7 instead of 27, which doesn't really make a difference in derivatives. Okay. It's like, man, I feel like deja vu here. This one's actually easier, isn't it?
Probably.
Okay, now we're going to,
Subtract 2x minus y.
okay, separate the dy dx's from the regular term. So I'm going to keep x dy dx plus 2y dy dx. I'm going to subtract over minus 2x and minus y. If you didn't on the last step, you now need to factor out a dy dx. I have x plus 2y in my parentheses. Whoops. And so then dy dx is negative 2x minus y over x plus 2y. And if you're like me, this problem is getting very confused with the 2x's and the 2y's and the x's and the y's, and I can't keep it straight. Okay, that is our derivative. Let's talk first of all, horizontal tangent lines. What do you know about a horizontal tangent line?
The denominator equals 0.
Okay, generalize here. What do we know about a horizontal tangent line?
Slope is 0.
Slope is 0, yes? So in a horizontal tangent line, we're looking for when is dy dx equals 0, right? Because a horizontal tangent line has a slope of 0. Now, our dy dx is a fraction. When is a fraction 0?
The top is 0.
When the numerator is 0.
I'm thinking it does not exist.
Okay, so in all honesty here, because this is a fraction, you really only have to worry for horizontal about the numerator. So you can just set negative 2x minus y equal to 0. Now, here, let me, oh, no. Now you give me a huge big eraser. I didn't want a big eraser. Just wanted to erase that little spot. You can think of it, if you want, as negative 2x minus y over x plus 2y equals 0. But think through it this way. What happens when I multiply x plus 2y over to the other side to get rid of my denominator? It's multiplying by 0, isn't it? And so that's how we can just go straight to negative 2x minus y equals 0. Okay? Let's see. What I did here, so I'm trying to remember, is I solved this equation for y. So if we solve this for y, what is this going to be?
Negative y equals 2x. Or plain usage. Y.
2x minus 1. What? Yeah.
No one liked that. Yikes.
You just toss
liked
it. You just toss the negative on one side, just toss it over to the other side.
Because it would be negative 2x, and then you move it over to the positive 2x, and then you times it by negative 1 to make it negative 2x.
Or I want a positive y term, so I just added y to my right.
What?
Or
And got y equals
totally
negative
that.
2x.
I took the.
I did it the complicated way.
I think all of you did. Or at least most of you, because there's a lot of thought processing going here.
Well,
I was not trying to confuse with this step, I promise. This step was supposed to be an easy one. It did not get seen. My apologies. Are we there?
Yep.
Y equals negative 2x. Whew. Now, I am running out of room because
How much more do we have to do?
a lot.
A lot.
We still have to do vertical. That's my thing. I have to leave room for vertical. But here's the deal. We're looking for points here, yes? If we're looking for points, we need x, y values. Okay? We know horizontal tangent lines happen when y equals negative 2x. We have an equation that combines x and y, yes? So the direction we're going to take this is we're going to use that original equation. Every place I see a y, I'm going to replace it with negative 2x. Now, keep in mind, we still have to do the vertical half of this problem. So space accordingly. My spacing, not working out. So x squared is going to stay x squared plus x times y. So x times negative 2x plus y squared. So plus negative 2x squared equals 27. Are you with me?
Yes.
And that is taking this right here and plugging it into those two places, yes? Okay, do some math. X squared minus 2x squared
Plus 4x squared.
plus 4x squared equals 27.
X squared equals 27.
1 minus 2 plus 4 is 3x squared equals 27.
X squared equals 9.
Oh my god, what am I doing?
Plus 1.
Okay,
And then you
3x squared, divide by 3. X squared is 9. And then you take the square root, and x is
plus or minus 3.
plus or minus 3.
And we have to
Now,
do the plus or minus because it's not equal.
these are horizontal tangent lines. Think about it. Do they make sense based on my picture?
Yes.
Where's a horizontal tangent line going to be?
Right there.
Right there, yes? It's going to be tangent at 3. 3 comma what?
3.
3 negative 6.
3 negative 6.
Oh, shoot.
Now, could you take the 3 and plug it back into an equation and find it? Yeah, we could take the 3 and plug it back into this equation and find it, but I'm taking the shortcut. Does negative 3 make sense? X value of negative 3, does it make sense there's a horizontal tangent line there?
Yep.
Certainly does, and that's going to be at negative 3 comma 6. And so I think I'm just going to put these down here. What'd we say?
3 negative 6.
3 negative 6. Negative 3, 6. Those are half of my solutions. That was horizontal. What do we know about vertical tangent lines?
That's easier numerator
X
denominator.
equals
The biggest.
What do you know about the generalize here? What do you know about the slope?
0.
0 is when X
Doesn't exist. Y equals.
Slope is undefined or does not exist.
Oh, yeah.
Okay, so horizontal slope is 0. 0 as a fraction is 0 over some number, yes? Vertical, the slope is undefined, number over 0. Okay, so now we're going to be looking for where dy dx is undefined is what I actually have dne. Okay, I don't think Kylie's feeling it today. Okay, so it's dne,
This is what I was talking
but the idea here is that this is some number over 0. So based on our slope right here, so our problem was negative 2x minus y over x plus 2y. We're trying to figure out where does that not exist. So what do we have to do now? Now it's the denominator equal to 0. So we're going to set, what? I am taking up too much space here. So we're going to set our denominator, x plus 2y equals 0. Based on our original equation, it's probably still going to be easiest to solve this for y. Okay? I'm trying to think. Well, could we do it the other way? Might be able to. I say, I did mine as
Negative x over 2.
2y equals at negative x, and so y is negative x over 2, negative 1/2 x is what I wrote. It's all the same, yes? What I'm looking at, and I don't know why, there had to have been a reason at the time, could you have maybe done x equals negative 2y and plug that in up here? You could. I think it will work out. Okay? Now, this one works out too, so let's do it. X squared plus x times, what's my y this time? Negative 1/2 x plus y squared. So that's negative 1/2 x quantity squared equals 27. X squared minus 1/2 x squared plus 1/4 x squared equals 27. My brain says 1x squared minus 1/2 x squared is a 1/2 x squared. A half plus a fourth? 3/4, right? 2/4 plus a fourth. So this is 3/4 x squared equals 27. Easiest way to move the 3/4 is to do what? Multiply by 4/3. So then I'm going to have x squared equals, when I multiply by 4/3, my brain does not pick up the calculator. My brain says, oh, 3 divides by 3 is 1. 27 divides by 3 is 9. And 9 times 4 is 36. X is plus or minus 6. Now, does that make sense? Yes? Okay, so 6 comma negative 3, surprise, surprise, and negative 6, 3. Those are your verticals. I looked at my graph.
That's not.
Okay, I looked at the graph to not make this problem any more difficult than it already is.
No. I was trying to, because I thought vertical line didn't have a line. But,
The equation would be x equals a number, but it can still have y values in its points.
yeah.
So, okay, you guys have some work time for 5 pages.
Yeah, 5 pages.
But it's 15 questions. If that tells you anything.
That
Some
really
of
doesn't.
them
It should.
have lots of space for work.